All right, guys, so we're going to start off by looking at exercise 7.41, problem number 26. So this is pretty much the whole problem. The only thing I didn't write in was our first expression was x squared minus 25. It actually factors to x plus 5 and x minus 5. On some of these here, especially if you're working through them and you notice one of the denominators is not factored, there's nothing that says that you have to rewrite it out first and then in the next step write it out factored. So when you start the problem, especially on paper, might as well start off with factoring them so you're not having to just rewrite it multiple times. And that's what I normally do. When I write it out to start, I will factor, bless you, any place that needs it. Now we need to see what we're going to need to multiply each one of these by. Well, our least common multiple, to get these all be the same, well, we're going to need an x plus 3, x minus 5, and x plus 5. We're not to get the denominators to be the same. Now, our first one has the x plus 5, it has the x minus 5. It does not have our x plus 3. So we're going to have to multiply it on top and bottom by x plus 3 minus. The middle one has x minus 5, but it does not have x plus 5 or x plus 3. Last one, 3 over x plus 3. This last one's missing x plus 5 and, I'm going to rewrite the top here in a second. So x plus 5, x minus 5, yes, because that's what it's missing. Now the denominators are going to remain factored because that's just part of the process. We don't need to multiply those out, but the numerators we do, yes? Well, where did we get x plus 5 and x minus 5 from? Well, we got it from our x squared minus 25, yes? I'm going to have to multiply them back out anyways, so I could write this numerator as x plus 5 times x minus 5, or I could just rewrite it as x squared minus 25, because x squared minus 25 factored x plus 5 and x minus 5, so therefore it should multiply back together to be x squared minus 25. Do we kind of see that there? And anytime we can do that where we have the two factors being multiplied back together, might as well just replace it with what it started with. Now at this point here, our first numerator is going to be x plus 3 times x plus 3. Now since it is in the numerator, we are going to have to multiply it back out. Minus our middle one, x minus 1 times x plus 5 times x plus 3. And here I'm going to go on and multiply it out. The reason I'm multiplying this last one out is we have a single number, single expression. There's not a whole lot to this one here. 3 times x squared is 3x squared. 3 times 25 is 75. Now, at this point, we're going to start distributing. Okay, so we got to start multiplying this out. I'm going to preface this right here because I hope at this point doing distributive property is not something that we're struggling with at this point. Would you all agree with that? Okay, because I'm about to start skipping steps. And what I mean by that is here we're going to multiply our x plus 3 and x plus 3. When we multiply those together, what we'll end up with is x squared plus 6x plus 9. So I'm not going to do the whole distributive property out. I'm just going to go on and give that to you. The next one, we need to just pick two of them, either x minus 1 and x plus 5, or x plus 5 and x plus 3. Doesn't matter which ones we pick. I'm going to leave the x minus 1 for later. But the other one, our x plus 5 and x plus 3 will multiply together to give us x squared plus 8x plus 15. I'm doing that mainly so that we can save a little bit of time on this problem and a little bit of paper on your, or room on your paper. And I'll move here in a second. Now we need to multiply these last two together. I'm going to go on and just fully multiply this out. And we get this here. Now we can't combine like terms in the middle. Apparently, it's going to scroll. X squared plus 6x plus 9. Our like terms in the middle, we'd have x cubed plus 7x squared plus 7x minus 15. And luckily, this is the last time we're going to have to write the denominator 3 different times. Question on this so far? I think you're noticing with this problem, it's not so much difficulty, it's more tedious. It's just tedious and long. And if you want, you can go back and rewatch this and get it down, because this will be included in the video. Now that we put them all together, we do have to make sure our signs are okay. X squared plus 6x plus 9. We distribute the negative through the middle term. Now at this point here, we combine like terms. Negative x cubed is the only x cubed term. We have x squared minus 7x squared, which is negative 6, plus 3x squared is negative 3x squared. Positive 6x minus 7x is negative x. And that's it. 9 plus 15 is 24 minus 75. 24 minus 7. Thank you. 51. And that's it. Just a lot of steps, but overall process didn't get any harder. It's just a lot of little steps. And luckily for this one here, I will tell you right out, the numerator doesn't factor, because at this point we would try to make sure it doesn't factor by grouping different processes, but it doesn't factor. So that is as far as it goes. Now again, I said that having the greatest or least common multiple, least common denominator is important, because if we had something more than that, we added another x plus 3 or x minus 5 into this, the numerator would not have a degree of 3. The biggest exponent wouldn't be 3, it would be 4, and there would be a common factor that we'd have to try to figure out how to get back out. And it would have made the problem bigger than it already is. Questions on this here? We okay with this? I know that was really quick and that was very fast. But if you haven't done it, again, go back, you can rewatch the video and kind of work your way through it. It is somewhat helpful to go through, if you haven't already, just to kind of get used to the process. It's bigger than what we were doing, but any other questions? Okay. I'm going to address the AMI packets because they did have us pass those out. If we're out a single day, first day, 2, 3, each one's labeled by days. If we are out 0 days and you still want to turn it in and do it, that is fine. I will take it for a grade. So if we're not out any, you can turn all 3 in, and I will give you a grade on all 3. If you don't, and we're not out, it's not going to hurt you. So if you do it, it can help your grade. If you don't, it's not going to hurt it. Does that make sense? Yeah. So if we're not out any days and you don't do it, that's fine. If you do, I will get, if we're out for AMI, yeah. Mm-hmm. Keep change, because that's our 732. Everything on the AMI packet stuff we've done up to this point. I'm not putting any solving, anything we haven't done yet. So it is good practice if you want to go through it. If you do have questions on it, email me. We're going to start off with where we left off yesterday. Simplify the complex fraction. Again, we're looking for the least common denominator. We're looking for what we need to multiply this by to get the fractions in the top and bottom to simplify out completely. So we look at the numerator denominator. There's 3 denominators in the top and bottom of this fraction. And we have x plus 5, and x minus 3, yes? Now, in each one of those spots, there's the x plus 5 only appears how many times? It appears twice, but in each denominator it only appears once. So the x plus 5, we're only going to need it once as a part of our least common denominator. Now the reason we would need it twice is if the numerator in the bottom had x plus 5 times x plus 5. If it appears in one of those spots twice, then we need it twice. But since it only appears once here and here, even though it's there twice, it's only appearing once on any of these 3 fractions. Do we see that distinction? Yes? Anything else we need? X minus 3. Now we multiply our numerator. X minus 3 times x minus 5. We're going to multiply with our 3. 3. And that takes care of it for now. The denominator, x minus 3 times x minus 5, will be multiplied with our 2. 2 times x minus 3 times x plus 5 over x minus 3 plus x minus 3 times x minus 5 being multiplied with our 1 times x 5 over x plus 5. Now some of the ones we did yesterday, we did have a multiplication that took place, but that's because we had something outside the parentheses in x, a number, that we went on and multiplied it with. So those simplify nicely. We're not going to distribute through yet. Partially because if we look at the numerator, our x plus 5 and x plus 5 cancel. In one of the denominators, we have x minus 3 and x minus 3. In the last one, we have x plus 5 and x plus 5. We don't want to distribute through those parentheses because there should be something in common on top and bottom. And those will cancel out. And what we're left with is 3 times x minus 3 over 2 times x plus 5 plus x minus 3. Questions on how we got to this point here? Are we good with getting here? Yes? Now it's very, very tempting to want to cancel the x minus 3 and x minus 3. Because what's in front of our denominator is x minus 3? A plus. That addition sign causes it problems because it's being added to something. Now if it had been multiplication, if the denominator was 2 times x plus 5 times x minus 3, then we can. If we get it in multiple sets of parentheses, then they cancel out. If we have multiplication on top and bottom. But if there's addition or subtraction between them, it doesn't work. Because of this plus in the middle, we can't just cross out these two here. Does that make sense? Yeah. So when you start wanting to simplify, look and see if there's any addition, subtraction between the terms. If there is, we can't. If it's just straight multiplication, they're right next to each other, top, bottom, we can. Now, the denominator, we can distribute the 2. 2 times x is 2x. 2 times 5 is 10. Plus x minus 3. Since there's not a number in front of it, we can drop the parentheses and we're good. And the reason we're doing this distributing and doing all this here is so that if there are like terms, we can combine them, yes? A numerator. Is there anything else we're adding or subtracting to that? No? We can. There's nothing wrong with me multiplying the 3 through. But if it simplifies, I'm going to have to take that 3 back. Now, since we don't have anything here being added or subtracted or anything here added or subtracted, there's no reason to multiply it through. The thing, we did that yesterday. And it's very, even for myself, it's gut instinct to multiply through. But then we see that there's nothing else. Greatest common factor of 3. We pull it right back out. The denominator, 2x plus x is 3x. There's a chance that we could simplify that front 3, yes? Let's combine our other terms. 10 minus 3 is? Well, 3x and 7 don't have a greatest common factor. So that's it. Questions on this here? Questions on anything we've done so far? Least common denominator, we need to see what we need to multiply to get the fractions on top and bottom to cancel out. What's one thing we know we'll need from these two here? A minus 2 and A. Because our A and A minus 2 are two completely different terms or different expressions entirely. Because it seems like one's just A and one we're just taking 2 from it, and we can just say A and negative 2. But the A minus 2 is a single term. It's a single expression. And our A is a single expression. Now we're going to multiply through by this here. So we have A times A minus 2 times our 1, which is A times A minus 2 all over A. Minus. We still have our 3. We still have our A minus 2. But we're multiplying the 3 by our A times A minus 2. Yeah. You're good? Now we're going to look at the denominator, and the denominators of our denominator are still going to be A and A minus 2, but we're going to multiply 2 by our a times a minus 2. So we'll have 2a, 2. Multiply our 5 by it also, so 5a times a minus 2. Now with the numerator, the big difference between our single a being multiplied with our terms and the a minus 2 is since it's out front, there's no reason to put another set of parentheses around that a. Because we could have put it as 3 parentheses, a close parentheses, then our a minus 2. A little bit unnecessary. Now let's see what cancels. A and a minus 2, a minus 2, a and a minus 2, and a minus 2. Which leaves us with a minus 2 minus 3a. Here, so I'm going to write this out to the side. So we have 2a times a minus 2 over a, yes? So the numerator is multiplication, because we have 2 times a minus 2, yes? So what I could say, and this is kind of rearranging it the way I want, is that I have my 2 times our a minus 2. In the other numerator, I can put my a, because all I did was spread it apart. And that's still the same thing, because if I multiply it back together, we'd have our 2 times a, and this here. Now the denominator is just a. I can, yeah, so I can do this here. Now if we set a plus 2 over a, well, we would have a over a, that's fine. But to get that, we would have to add to it 2 over a, because the denominators have to be the same to add or subtract. The a over a would simplify, giving us 1, but now I have plus 2 over a. So it's, yes, it's able to simplify, but we didn't actually get simpler. We got a little more complicated. Can we kind of see the difference? And this is one of the few times that addition and subtraction is not easier than multiplication. Normally it's the other way around. But with our fractions, that's why it works that way. And again, keep asking questions, because then I can actually address it, and now it makes a little more sense, yes? So we can see that there, because here, again, one of those cases where a minus 2, a minus 2 on top and bottom, but that pesky minus sign is in the middle, yes? So I can't just cross those out, because it would be just like we had a minus 2 over 2 times a minus 2 minus 3a over 2a times a minus 2. It doesn't simply cross out. Plus 5a, thank you. Now, any other questions on how we got to this point here? We good about getting to here, yes? Top and bottom of this fraction, are we going to have to combine like terms? There's a chance, yes? Because we have addition, subtraction, there's a good chance we might have to combine like terms. The numerator a minus 2 in parentheses, there's nothing in front of it, so we can just drop those parentheses. We don't need them. The denominator, we do have to distribute the 2. 2 times a is 2a. 2 times negative 2 is negative 4 plus 5a. Combine like terms, a minus 3a is negative 2a minus 2. The denominator, 2a plus 5a is 7a minus 4. I factored out a negative 2 out of the numerator, greatest common factor. Now the reason I did negative 2 is, well, both of the numerators were negative, 2a minus 2. I'll take the negative with it. Doesn't mean I have to. I could take out 2 and have negative a minus 1, that's fine. But part of the reason I take the negative with it is we have a strong tendency to want to keep those variables, especially the one with the biggest exponent. In this case, that's just a positive, just in case the one in the denominator is. Does that make sense? Trying to line them up. So we'll take the -2 just in case something would match up. Well, 7a and 4 don't have anything in common. So that's as far as it goes. Questions on this here? Question on anything we've done so far? What do we think about these here? All right. I will say this here. For those of you thinking about going to college, I would try to take college algebra next semester, either concurrently, or I do offer it here, so you can actually take it with me, either way. And it's not as bad as you think it is. That's essentially what we do in here, just one step farther. I'd say about 85% of everything we've done, or 80 to 85% of what's in college algebra, we cover here. So it's a small portion. I don't know if you heard that last statement. That about 85% of what we do at Algebra 2 is covered in college algebra. Yeah. So it's very little in each chapter of what's extended. So hopefully that gives you a little bit of a breather. It kind of makes you feel a little better. That's part of the reason we have Algebra 2 in high school, is to help get you ready to be able to take it. Questions on this here? No? I think, would y'all say that y'all feel pretty comfortable with these here? One more practice? One or two more? I'll let you pick the next one or two that we do. The XY? Yeah. Now, we need to find what we're going to multiply everything by. Yes? Well, on top and bottom, we do have a squared term. Yes? X squared and y squared. And we do have x and y, yes? I'm going to start off with this here. Now, with addition subtraction, x plus 2, x minus 2 are completely different. X and x minus 2 are completely different. Yes? Here, we don't have addition or subtraction in the middle term. So, and the nice thing with mathematics and using an eraser is we can try this here, see if it simplifies. If it doesn't, we can go back and fix it. So let's just start off with x squared and y squared. Because if we multiply our first numerator, we'd have x squared y squared over y squared. Y squared over y squared will simplify. Next one, x squared y squared times 1. That'd be x squared y squared over xy, yes? Will x squared over x simplify? Yeah, because it's just multiplied, x over x, y over y. So luckily we didn't need an xy term, we just needed the x squared y squared, because x over x, or x squared over x, y squared over y. Minus, our last one's going to be 2 x squared y squared over x squared. Do the same thing in the denominator, x squared y squared times 1. X squared y squared over y squared minus 3 x squared y squared over xy plus 2 x squared y squared over x squared. Huh? Now, the first term, y squared and y squared is gone. Third term on top, x squared and x squared is gone. So our first term is x squared minus 2y squared. Denominator, y squared gone. X squared gone. So I have x squared minus plus 2y squared. I did those first mainly because it's easy to see x squared and the y squared corresponding spots gone completely, cancel out. Now, with the middle term, we have x squared over x. One of these x's will cancel with one of these, yes? And this one y will cancel with one of these y's, also giving us. So here we have two x's on top, one on bottom. 2 minus 1 is 1. Since it's bigger on top, it stays on top. Y squared over y. 2 minus 1 is 1. Bigger on top stays on top. The denominator will still have our 3, and we'll have the same thing. This x will cancel out with one of the ones on top. Y will cancel out with one of the ones on top, leaving us with negative 3xy. Questions on this here? Question on anything we've done so far? Have we factored one of these, something like this on top and bottom? Well, we kind of, but we haven't had it in this form, x and y, right? Well, as I've said with factoring, and we've done factoring time and time again, I like the method that I have. And if you noticed, there's very much a distinction between our variable being squared, our constant term, none of that verbiage in it. Because when we look at the numerator, no greatest common factor, so we have two sets of parentheses with three spaces, yes? If the third term, not constant term, if the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite, yes? Third term is negative 2y squared, so since it's negative, signs are opposite. Now we want to find the factors of the first and third term. Factors of the first term is factors of x squared. Well, the only factors of x squared are x and x. And the factors of the third term, not the constant term, the third term, yes? What's our third term? Or just 2y squared, yes? What's factors of y squared? Y and we need 2. Now, negative. So we need the 2 to be negative. So has anything changed in our steps, even though we had y squared in the third term? No. That's why I like it. Just because we have variables now in the third term, all the steps still hold true. Now I'm checking, because x times x is still x squared. Y times negative 2y is still negative 2y squared. Those are still true. X times negative 2y is negative 2xy. Y times x is plus xy, which leaves us with a negative xy. Questions on this here? Let's look at the denominator. No greatest common factor, so we have two sets of parentheses with three spaces. Third term is positive, so the signs are the same and match the sign of the middle term. Factors of x squared, x and x. Only factors of x squared. Factors of our third term, 2y squared. What factors of y squared are? Y and y, yes? Factors of 2 are 2 and they would indeed. And we could check it. I'll do that off to the side. X, because it'd be negative 2xy minus xy is negative 3xy. And yes, negative 2xy and negative 2xy would cancel, leaving us with x plus y over x minus y. And I would agree, the whole process for this problem is kind of has a prettiness in its essence of how it worked out. Now, we did talk about restrictions and that the denominator can't be 0. Well, here we're just saying that x minus y cannot be 0. Solve for x or y. So as long as whatever the value of x is not the same as y, we're fine. Then it would cause an error. There's more, especially getting x minus 2y, we're not going to focus on yet. But purely for this here, it would be that. The other case is that x cannot equal 2y, because it's just x minus 2y. Solve for x. But questions on this here? We're going to have to stop there, because as much as I would want to do this one or the previous one, and there's only 4. We quite don't have the time, the 3 minutes to try to get it all in. That's it.